Good evening, everybody. Joe from NDB Aviation. I finally have enough time off between flying to put together some content and get it ready for YouTube and for you all to watch and hopefully like. This is the first video that's going to be part of a series that I'm going to do. It's called Flight Basics. I will be doing my best to give a very basic flight sim lesson to anybody who wants to watch and learn a little bit more about aviation, but in a very plain and simple speech pattern way. I don't plan to go full in depth like I would if I was going back with a flight student right now, going back to my old CFI ways. No, this is going to be a very plain language, easy to understand explanation. And if you are already a flight student, if you are an already advanced sim user that understands aviation and physics of aviation in general, this might be boring, but I'm sure you can turn this into something fun, whether it's a water drinking game, coffee drinking game, or tasty adult beverage drinking game. There are going to be certain words that I use quite regularly throughout the video, and maybe you can make some fun out of that, or make some fun out of me. But overall, these videos are going to be very simple and plain language in aspect for anyone to understand. Some of these videos will be done in Microsoft Flight Sim 2020, others will be done in X-Plane 11, and then hopefully at some point in the future, X-Plane 12. I'm really hoping to see that sometime soon. But the reason for that is some of these videos are going to be so basic, we're going to go for something that's visually appealing for everybody to see versus X-Plane 11, where it's really a very lesson-based flight simulator, and the visuals just aren't that appealing right now anymore. Each video, I will tell you what I'm using for flight sim peripherals. For this video, which will be pitch plus power equals performance, I will be using my Honeycomb Aeronautical Alpha Yoke and my Honeycomb Aeronautical Bravo Throttle Quadrant, paired up with my good old Cessna Saitek rudder pedals down below. Now, whenever I can get my hands on a Charlie, whenever that will be, I will happily replace the Cessna Yoke with those. But as of right now, in the foreseeable future, I don't see myself getting my hands on those. But without further ado, let's jump into the sim. This is the only time where you're going to see my ugly mug before any of these Flight Basics videos, unless the video itself requires an introduction to set up anything specific for that video. So thanks guys for watching. If you like these, like and subscribe. But especially the one thing I want to ask, if you've stuck around this far and you're about to go into the sim with me, please leave your comments in the comments section below to help me better make these videos for anybody to understand aviation. I want this to be very simple in nature so that anybody can watch this video, go into the sim, fly in the sim, and eventually if they're really hooked in aviation, they can go fly an actual flight lesson with a flight instructor and already have some basic ideas of how this is going to work, and then the instructor can lay out the actual phraseology for all this stuff, and it clicks instead of taking hours and hours for it to beat into their head. So thanks for watching, guys. Let's jump into the sim now. Well, everybody, let's hop into the sim here. At this point, we're going to start every one of these lessons, unless we need to start in the air, on the ground. Today we're going to use the Cessna 172 with the G1000 suite on the inside. We're going to go ahead and hide these yokes because we're not going to be spending a whole lot of time inside the cockpit. We'll be going in and out of the cockpit to talk about pitch plus power equals the performance you want. So let's first start off, what is pitch? If you don't know what pitch is, then let's make this really simple for everyone. Look up, look down. Now imagine when you looked up, you were the aircraft. That's pitching up. When you look down, that's pitching down. This is basically how we leave the runway, but we use the yoke or the joystick to get us away from the runway, but also we need power. Now, with these two relationships, we have pitch and power. We need excess power, or lots of power, to get us off the ground. So basically, as we start increasing the throttle, we are creating more power to then move us forward and get us rolling. Let's get the parking brake off. Here in this video, we are in Duluth, a place that I do miss flying to. And we're going to take off. It's early morning with scattered layer of clouds. We aren't going to have to climb very high. But as we accelerate, we're using the power from the engine to move us forward. And then we're creating lift over the wings, which then helps us leave the ground. Sorry for that messy takeoff. But there are certain things that we can already start talking about here. Pitch plus power equals performance. Now, I need a pitch up attitude, which you can see right here on the G1000. The pitch up attitude is about 10 degrees up, 5 degrees up, and we have full power. We're still accelerating as well, which means we have excess power for this pitch. One thing we can do to make this a little bit easier is with my Bravo throttle quadrant, I can use the trim wheel, fine tune the pitch. I got to keep my foot on the right rudder a little bit for P factor, and I can trim out the aircraft to pretty much fly itself and keep us climbing. Now, what you'll eventually find in this video is for each power setting and each pitch setting, you get a desired performance. Right now, our desired performance is a climb at about 90 knots and somewhere above 500 feet per minute. We have our airspeed over here, and then over here we have our climb rate, vertical speed. We're going to climb up to about 3,000 feet, and then we're going to move on to the next portion of this video that's a flight basics video. We want to fly straight and level, or as straight and level as we can, with the aircraft's desired performance being no gain in altitude and no loss in altitude, while fine-tuning our actual pitch attitude, how much we pitch up, whether by looking out on the horizon, or how much we pitch up by looking at our PFD right here, our primary flight display on the G1000. Now, as you can see, it takes a few minutes to get up to altitude in a Skyhawk. I did weight it down with full fuel and 2 pilots inside of it, because I do believe that a heavy aircraft usually flies a little bit better than a light aircraft. Now, as I turn left, I do need to pitch up just a little bit more to make up for that loss of lift, because we are turning. Anytime we turn, we aren't pointing the tail straight up. So an easy thing that you can always remember is, while we're flying around, anytime the tail isn't pointing straight up to the sky and you want to stay level and not lose altitude, you need to increase your pitch up attitude to keep your airplane at that desired altitude. Now here comes the fun part, and let's talk about a few caveats to flight simulation. Unfortunately, trying to find the perfect attitude while flying in a flight simulator can be very difficult. While we're flying in an actual regular flying lesson, it's real easy to find the horizon, pitch for it, set the power, and trim it out. But in a simulator, we have to do something that I tell my VFR students not to do. We're going to use our instrumentation, which is a big no-no for a brand new flight student. Another thing you can use, because the G1000 is pretty cheater, let's go ahead and set our power first, and we're going to start with a cruise power setting. We're going to be looking for about 2350 RPM. That's something easy on the engine. And with the G1000 here, we can use our little pipper, this little green dot going back and forth on the horizon. You can pitch it for the horizon here, and then try to trim out the aircraft. As you can see, we're slowing down. So what we're going to require, since I brought the power back, is a little bit more pitch to hold our altitude. Over here on the right, you can see our vertical speed was gaining. We want to go back to 3,000 feet. Now looking behind the airplane, it's tough because we have this live shaky cam view. Now let's try to just put the tail right here as best we can. And now I have the power setting the way I want it. On the G1000, it's 2180, so yeah, we need to bring that power back up because this is not a constant speed prop, meaning the propeller RPM changes depending on your overall speed. And that's for another lesson, but let's try to keep this simple. Look at the G1000 here. We're going to try to keep the vertical speed at 0 and hold 3,000 feet at 2380. This is going to be close enough, 2400 RPM. We are heavy, so the airplane should be a little bit more stable and easier to fly. If I let go of the yoke, the airplane's going to pitch up. So let's fix this by using trim. I'm going to bring the aircraft back to the horizon on the G1000, and then I'm going to use my trim wheel. Since I have to keep pushing forward on the yoke, or if you have a joystick, you're pushing forward on the joystick, we need to use pitch trim nose down. And with the Bravo throttle quadrant, this is really easy because I can really fine-tune the pitch trim with this trim wheel versus using the pseudo electronic trim on the yoke itself. I can fine-tune it and I can get the overall pitch that I want with the power setting I want to then give myself the performance of straight and level flight. In real life, you can fly for hours like this. You don't need an autopilot. And if you master the overall power settings and trim settings for your aircraft, it will be a lot easier to just have fun in the sim and do a lot of the other things that you want to do. Let's go and turn off our landing light and our taxi light. We don't need those anymore. Now, I do want to stay close to the airport, so I'm going to come back around the shoreline here in Duluth. Now that I'm turning, if I don't pitch up slightly, see the vertical speed is dropping. So to continue our desired performance of 3,000 feet, I'm going to have to increase my pitch attitude a little bit to regain 3,000. And we'll just follow the shoreline back this way now. Now, as the aircraft stabilizes again, I don't have to make any more changes on my trim. Pretty much everything else that's going to happen now is the aircraft speeding up, slowing down, and finding what you would call its point of equilibrium. And that's what you want when you're flying. You set things to be equal, so your pitch is going to be sufficient for your power setting. Now, to continue talking about this, these two sets of equilibrium come down to your pitch attitude, whether you're going to be pitching to the sky or pitching to the ground, and your power setting. So right now I'm pretty well trimmed out for 2420, 2400 RPM, see it over here on the right, and 3000 feet. If I bring the power back to 2000 RPM, the airplane is going to naturally want to descend because now we don't have the required power to maintain this pitch trim attitude. This is something we do in aviation to also make the aircraft descend at a specific rate. A private pilot that's working on their instrument exam or instrument training is going to figure out specific pitch settings and power settings to make the airplane do what they really want it to do. Now, after a while though, the airplane will find a new state of equilibrium, but most likely it will remain in a shallow descent until reaching the ground. Now, if we bring that power back up, and let's go to full power, naturally the airplane is going to want to climb. Because when we trim the aircraft out for straight and level flight with our power setting of 2400 RPM, it was level and in equilibrium at 3,000 feet with 2400 RPM, aroundish that setting. Now we're up to 2620. The aircraft is going to want to climb until the aircraft reaches an altitude where the power coming from the engine is insufficient to keep it climbing. Now, as the aircraft speeds up here on the left-hand side, the indicated airspeed, the aircraft will start to pitch up again. If we let this go for about 2 to 3 minutes, eventually the aircraft will find a sweet spot between about 2.5 to 5 degrees pitch up and be somewhere right there to maintain it for quite a while until we get so high that the propeller and the engine loses efficiency to create that excess thrust. Like I talked about at the beginning of the video, we require excess thrust to make the aircraft climb. So we've talked about how pitch and power affect our performance, and performance again is what you want the airplane to do. Sometimes you want it to descend, sometimes you want it to climb. Other times you want the airplane to just cruise around at a perfectly fine-tuned power setting so you can maximize your endurance. So let's come back down out of the scattered cloud layer here. Come back down to 3,000 feet. I'm going to pull the power back, and this time we are going to retrim the aircraft for 2,000 RPM. And we're also going to start working our way back to Duluth International Airport and eventually come in for a landing here. Now, the reason why we practice pitch plus power equals performance is it makes you a better pilot, especially for doing landings Landings really work out this balance, a better understanding of how to utilize your aircraft. Because without understanding pitch and power, your landings are going to be terrible. You're going to be fighting the aircraft all the way to the ground. And if you're really going for those landing challenges and trying to be the best you can at them, you need to understand how your aircraft flies. When I was working on my instrument rating, we utilized tables to better find out exactly what I should set the pitch to for an aircraft to then get the performance I wanted for, say, flying down an ILS or an LPV approach, or even a localizer that was timed, or worst case scenario, doing an NDB or an ADF approach, which one of these days I'm going to make a video about. So we've already achieved straight and level flight once, and here we are. We're back at about 2,000 RPM. We're slightly below 3,000 feet, but we're pretty well set. Looks like we need just a little bump and pitch up. So we're going to use the trim wheel on the Alpha Yoke, or on the Bravo Throttle Quadrant, to get that just right. And now we're going to let the aircraft cruise. Here we're at a pretty good cruise setting. We're about 84 knots, 85 knots. And this is where the Skyhawk, you can dump out all the flaps if you need to. There's the airport over there. We'll make our way over there in just a minute. But we can show the direct relation of a specific pitch with a specific power and trimming it out to make the aircraft fly straight and level the way we want. Now let's do something a little bit more intriguing. So at this point, we've pretty much set up everything we want to do with pitch plus power equals performance. We've talked about retrimming the aircraft. We've talked about changing power. Excess power gives you a climb. Reducing the power from your state of equilibrium gives you a lack of power, which then makes the aircraft want to descend, come back to the ground. And we've also talked about basically how a flight student would utilize these different methods to get the aircraft to do exactly what they want it to do. And again, in aviation, each aircraft, through years of abuse and use, will fly slightly differently than others will. So tables in the aircraft performance manuals aren't always going to be perfect, but they're going to be pretty darn close. And you can do those, especially within the simulator, because in the sim, they're supposed to be pretty close as well. Here we are. This looks like about a 4-mile right base turning into a sloppy final. And what I'm going to do is I'm going to descend from 3,000 feet down to that runway by bringing the power all the way back to idle. I'm going to dump out all of the flaps. I'm going to set up this Skyhawk for what I would call best glide with full flaps. Now, if we're going to do best glide, we're not going to have full flaps out because we're just creating a ton of drag. We can also utilize that little pipper here in the synthetic vision meaning we're seeing the ground on the PFD, to get over there. We're going to set up our pitch and trim. We have no power this time, so we have a lacking of power. So the aircraft naturally wants to come back to Earth. And we're going to trim out the airplane for a perfect glide to the runway. Now we might have to fine tune the flap setting because it looks like already we're not going to make the runway like this. So let's go ahead and bring the flaps up a bit. Reduce our drag profile, or how much resistance we're creating against the wind. And we're going to glide on down and make a landing on runway 27 here in Duluth. We're holding about 60 knots. It looks like we're going to make the end of the runway, but not the 1,000-footers. Let's just see how this works out. But in review, in this video, you have the basic knowledge of how to set an aircraft up to take off. You need excess power. You need to pitch towards the sky, but you don't want to go pitching too high because, well, you'll end up bringing the aircraft back to the ground. All right, let's just go and bring the flaps up, do a 0 flap landing. Here we come, coming in. But what the biggest thing I hope everybody takes away from this video is when you're flying the aircraft, you need to find a state of equilibrium to make the aircraft do what you want it to do. And that thing is performance. The performance is your desired outcome. If you want to fly straight and level, and you want the aircraft to stay at a certain altitude, well, you need to find the correct pitch attitude and power setting to maintain that altitude. If we had even more time and we wanted to go even more in depth, we could actually play around with different pitch attitudes and power without even changing the trim, the pitch trim, and make the aircraft fly straight and level by just utilizing pitch and power itself, no trim as well. If you guys have questions, if you want a further explanation, I'd love to hear it, and I'd love to even go back in depth, more so on pitch plus power, but I wanted this to be a very basic intro of pitch plus power equals performance. Leave your comments down below. If you guys want more content like this, let me know. Thank you, and have a good night.